Okay. I might be really loud. I turned down the volume. We'll see. Add fractions with like denominators. What we're going to be doing is we are going to add the numerators. Ugh. And write the sum over the same denominator. Turn down the volume. Okay. The sum of a whole number and a fraction is called a mixed number. The sum of a whole number and a fraction is called a mixed number. Yep. No. Good question. No, it's just collecting the. That would be if there was actually a camera filming this, but it's actually just collecting my screen capture. The sum of a whole number and fraction is called a mixed number. Called a mixed hashtag. An improper fraction is a fraction which the numerator is bigger or greater. Ooh, was that you or somebody else? You don't know? Where it is bigger. Where it is bigger than the denominator. For example, 5/4. And with this next one here, some of you may remember how to do this from last year, and you may know a couple different ways of doing it. And the textbook does not require you to make mixed numbers a proper fraction. However, or to make it an improper fraction. However, because some of us aren't as comfortable with positive and negative integers, we are I always need to change mixed numbers to improper fractions. And I must simplify my answers. I must simplify my answers. That's what I need to do. I need to simplify my answers. Says my good Aunt Sue. Doop, 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 doop. Okay, changing improper fraction to mixed numbers. So, also for YouTubers, I can't really do much right now because this is actually capturing upside down, having some technical difficulties. But that's why it's not maximized. But anyway, change the fraction 5/4 into a mixed number. The first thing we're going to do is divide by 5, or 5 divided by 4, to see how many times the denominator will fit evenly into the other numerator. And I'm going to go like this so I can see this up close. Now, what I'm going to do here, you guys don't have as many different colors as I do, but I'm going to show you where these guys end up. Right in the microphone. It's a cough. Sorry. Sorry, headphone wearers.
You still have that black coffee?
Yeah. Okay. Now, some of my students last period is like, wait, Mr. Smith, you said there won't going to be no more remainders. Why are you going to use a remainder? Okay. The reason I'm using a remainder for this one is because this isn't division. In this situation, it's finding a mixed fraction. So, here's what happens. With this remainder ends up in the numerator. Then, this whole number here ends up as the whole number. And we're still hanging out with our denominator. Okay, you get. Thank you. There's some good lines? Thanks. No. No, I don't have much free time. I just doodled a lot when I was in college. Okay. Hey, when you get old enough and you can focus and doodle, and remember important information. Okay. Yeah, exactly. You can usually do one of the two, and then when you get older, if you can do both, that's cool. All right. The whole number 1 becomes a whole number in your mixed number, and the remainder 1 becomes a new numerator, and the denominator remains the same. So even if you don't have these 3 different numbers or 3 different colors to be able to tell which one is which, and that really handsome-looking Jay Leno-looking guy, to look at the size of that chin. Yeah. There. Is that the wrong direction? It looks like a pimple.
No. His chin's gone.
It's from like Scooby-Doo or something.
All right. Adding fractions with Kate Upton. Adding fractions with Kate Upton. She's a model. Okay? That's fine. I would have said like models that were famous when I was a kid, but I think that people don't really care about models as much now as they do now. So, adding fractions with Kate Upton. So, Kate Upton tells us that this is 1/6. Okay? And they're like, wow, Kate Upton, you're smart. You can tell what 1/6 is. Let's add 2/6 to it. And then you add 2/6 to that one. And because you can see things and you realize, this could be, when added together, this is 3/6. This is 3/6. So the answer is going to be 3/6. But you recognize, as Corey just said, that's actually going to be 1/2. Because you recognize that this is half. I know. So this is going to be, which equals 1/2. Now, Kate Upton had to be somewhere, so she's gone. Now we are without. Now we're without a model. So the first thing that we're going to do is we're going to recognize our number sense here, and we're going to zoom in a bit, Ski. 125. Adding a fraction without Kate Upton. Add 3/4 plus 3/4. Now, let's estimate first. Okay? Let's think of our benchmark fractions. What do we know and recognize as being a certain amount of a number? And Sydney, if you had to guess, it's okay if you're wrong. What do you think it's going to be? Six-four? 6/4. Okay? Because we got fourths there. Now, you are just too smart for me. Can you tell me, do you think it's going to be about 1 or 2, or what do you think it's going to be? Around what? You're thinking too much for an estimate. Is it going to be around 1, 1/2, 2, 17,483? What? About 1/3. Okay, cool. About 1 1/3. About 1 1/3 maybe. Okay? Now, let's do this. It says here, first add the numerators. And I'm going to cross off this then here. I don't want to say then. I want you to say over. Over the denominators. Are we on the second page yet?
Yeah. Be on the back.
Okay, good. Over the denominators. So we're going to add the numerators. Which is going to be, what is 3 plus 3, everyone? 6. Thank you. You're so smart.
I have the answer
Okay, so we have added the numerators above the denominators. Then for the second step, it says to simplify if we need to. Can you simplify without making a mixed number first? A mixed number has a whole number and then a fraction. Can you give us a simplified fraction first? A simplified improper fraction? Yep. Well, not 2/4. What is 6/4 reduced to? 2. If you're dividing, so we got to divide this by something. That needs to be divided by something. That needs to be divided by something. Think of your divisibility rules. What's the first thing that's going to go into after 1? 2. So 6 divided by 2 is 3. 4 divided by 2 is 2. Good. Now we got it. Because I want to show each step that some of you might take tonight, so when you're looking at this YouTube video, you can know what's up. Okay? Now we're going to do it. So, Lainey, go ahead and tell me, what does 3 halves become? 1 1/2. And Sydney's guess, right here, about 1 1/3, that's a good guess. That's a good guess.
She's just a smart friend.
It's good to have smart friends. They make you better people. Well, more people who make good decisions. And you can help each other become smarter, too. That's how I learned all my Spanish. Now, adding mixed numbers with like denominators. For the reason of time, it's in your notes already, so I'm just going to do this quick. What we have to do here is we do 9 times 8 plus 7. 8 times 2 plus 1, which this is going to be 79 over 8 plus 17 over 8. 79 plus 17. Now that doesn't make my brain go, this is easy. But what is easy is if I borrow one from the other and I get 80 plus 16 is clearly 96 over 8. Oops, we forgot to estimate. I'm going to estimate, I'm going to estimate 11 or so. Maybe 11 and 1/72nd. Just kidding. 11 and 1/21st or so. Now, this is the way that not how your book does it. So if you don't like this way, you can see it in the book and you see how they do it. Now, we have 96 over 8. Before I get too much further, I want to point this guy out here. Because if something is equal to h, that means our answer is going to be h equals something. Please don't do that. H is going to be equal to something. So we have 96 eighths. So 96 eighths, I need to simplify it. In order to do that, I'm going to do, because it doesn't jump out at me what's going on with this. So I do 96 divided by 8. There's one of those, goes here, subtract. Let me get this out of the way so I can see it. You can't do that. 16, 1, bring down the 6, that becomes, that becomes 12. Which means that h equals 12. H equals 12.
If you would have put the 121, you would have been really close.
121.
Yeah.
So 8 equals 12. I love circling answers, so I'm going to circle it.
Well, he put 11, he was like 11, 127, so it comes over to 21. And he would have been so close.
Yep. And here's the way that some people did it. This is how your book does it. I guess I could show this really quick. Okay, what they did is they just took out the 9, took out the 2, plus 7 eighths, plus 1/8 equals 1. 1 plus 9 plus 2 equals 12. That's how your book does it. I'm just showing you that. Look at your book. It's on page 240 or so, 241. All right, now some of the questions that are on the homework that I want to make sure you understand. There was about a third of one of my classes that finished it in 10 minutes. So we're not going to be able to do that because we got held up because of technology. However, here's a couple that are going to be more difficult because of integers. Because of the integers. Let's see. We use these same colors all the time. Let's go with the magenta. So we have 9/24 minus 11/24. And when we have a number line, here's 0. Okay, we'll say that this is 1. We'll say that this is -1. Now 19/24 is going to be just about beyond halfway. Okay, just beyond halfway or so. Maybe that might be a little bit more this way, but you're getting the point. When I am taking away 11/24, since I am removing it, I could look at it by the additive inverse from the chapter 2 plus -24. Oh boy. So that's how that would go. That would mean I'm going this direction, -11/24. What is 19 minus 11? Or 19 plus -11? Is it going to be, well, first off, let's talk about integers for a moment here. Is it going to be positive or negative? Positive. That's because the number that is bigger is the one that's having stuff done to it. So the smaller number is being removed. Smaller number is being removed. That's like the sea of zeros thing. So we have what? What is 19 plus -11? Yeah. Is it positive 8 or negative 8? Positive 8. I tried to trick you. Okay, so 8/24 simplifies to what? Who have I not picked on today? Mulville. 1/3. I agree with you, sir.
Why couldn't you just do 19 minus 11?
Because we're doing additive inverse, and some people get confused with integers like that. It would come out to be the same thing. It makes you, what did I do at the very end there? What did I do before I circled it? Please stop. X equals, yes. X equals, because it's right there. You need to have X equals. Okay, next one. There's a couple more I want to get through. Yeah, we'll do this one. Let's do number 4. Let's do number 4. Now with this one, with the number line, we have, here's 1, here's -1, here's 0. Now with this one, I have 9/20, which is going to be just under halfway. And I'm removing, which means I'm going to be going that way, 17/20. So I ask you this point. If we were just talking about the numerators, is this going to be a positive or negative integer? It's going to be negative because the smaller number is being taken away by the bigger number, so we're going to be negative. So since it's a fraction, it's not an integer, but we're going to be just going with it. So we have 9/20 minus 17/20. Or if we want to do additive inverse, what do we have there? 9 minus 7, or 9 plus -17. Yeah, Raven. -8, you are correct. Which simplifies to 4, or -1. No, -2/5 equals m. -2/5 equals m. How are we doing? Any questions? Okay, good, because here's the confusing part. I did number 7 with all the other classes. I'm going to do number 8 with you all. Okay? Now, see how this m is on each of these? Okay, we learned about the distributive property early last year, so I've already gone over that with my 6th graders. And we've done the distributive property during the 2nd week of school. You all right, Jake? Good? Thought I lost you. Okay, we did the distributive property. Now what's happening here is these are all like terms. So what I can do is I can take the m out, and it would just be this. That m is going to chill out here. Okay, isn't this so much easier within these parentheses here? That is so much easier than to deal with that when the m is chilling by itself. This m is going to go on a vacation and hang out until the very end. Okay, this m, let's give him a little umbrella here. Okay, here's the m hanging out. Let's give him the beach towel. Let's give him a bucket here. Okay, there's the beach. Why a bucket? He's in the sand. He's going to play.
It's an M.
Of course it's an M. What else would it do, right? Okay. So this M here is hanging out on, where's yellow? This M here is hanging out by the sun. He's gone, okay? So just let him chill until we're done with the work. It's like when you invite one of your friends over to dig a hole because your dad won't let you leave until you're done with that. And then they just go inside and they don't ever help you, and then they come back when it's done. Anyway, we have 4/5, and then here's a 7th. If we wanted to make 7, so we had 4/5 here plus 7 firsts, because 7 divided by 1 is 7, plus 10 plus 13 fifths. Now this isn't going to go well because we need to have a common denominator. We need a common denominator. How are we going to make this become a denominator of 5? Sam?
Take both the numbers times 5.
So we're going to take both the numbers times 5. Beautiful. So what we have here is 4/5 times 35 fifths, or plus 35 fifths, plus 13 fifths. That becomes 39, 49, 52 fifths. Oh, that's a weird looking 5. Okay? Corey, you getting this, buddy? I just lost you. You getting this? Hope so. So then that comes out to be 10 and 2/5 to simplify really fast. And so we have a final answer. Now M is like, oh, hey, you guys are done? Let me just come back and hang out with you. Let's see here. Let me just do my thing. I'm going to come back, and boom, there's your answer. 10 and 2/5 M. And it did. I'm sorry. I went from magenta to like a violet.
I like the violet part.
Yeah. So your homework is section 5-4 practice, and that is the odds is what you have to do, because I asked a student in 4th period what their favorite number was. They said 33, and that is an odd number. If you have any questions, I'll be happy to answer them tomorrow during activity. I'm turning off my mic.